Today I've been experimenting with this type of balloon. This is called a sleeve balloon or bazooka balloon. It's a quite interesting device. It is intended to block or to minimize common mode current in dipole antennas. In my case, it's a Yagi antenna. And it is very good for UHF. Not that broad of a band. It has quite of a narrow band, but it works for UHF. So let me explain how it works. So this is how the device works. You have the coax cable going to the dipole. You assume it's matched. Here you have 50 ohms at the feed point of the dipole. So you add a tube outside the coax, and this tube ends very close to the feed point, as close as possible to the feed point. So you have as little as possible of coax showing a common mode. So here you connect this tube in the braid, and it works because of when you connect the tube here in the braid, the common mode current will see it here at very high impedance. This is because here you have very low impedance in this connection to the ground, and a quarter wave upwards here, the common mode current will see a very high impedance. So I built my device. It's not the best looking device you can think of, but I built mine in this way. This point is where the braid connects to the tube. I used only 3 thin wires. I tested with a disc, but I didn't find that much of a difference using wires, and they are much easier to solder. So here the tube, and I 3D printed this spacer. This is intended for hold the coax cable in place so the capacitance won't change. And I added also this sleeve here. It moves. If you try, let me show. It kind of moves, so you can adjust your cutoff frequency, your dip. So my target frequency is about 459 megahertz. Here you see the dip. And now I'm going to move this moving sleeve here. So I've increased the length, and as you can see, the dip moves to the left as expected, because as the electrical length here changes, so does the frequency. English is not my first language, so I'm kind of struggling to explain, but here the dip is right at my target frequency. I can maybe just decrease it a little more. As you can see, the setup is not ideal. I calibrated the Nano VNA actually with the cable hanging like this, so it minimizes the capacitive loading. And in this position, the attenuation is close to minus 30 dB, so quite good actually, and quite narrow in band, but quite good attenuation.